Okay, already?
Already.
Okay. Any particular one you want to ask? If not, we will go one by one. I think essay one is important. In fact, it's much easier. Since I do the question, I know it looks much easier than the multiple choice.
Yes, Archer.
Multiple choice, you get 1 mark only.
So, yeah, no point.
And you have to do all the 3 different mark. If you do a structure or essay, you get 3 marks. Doing all the steps.
One by one.
Yeah, you do all the step one by one, you don't get any mark there for multiple choice. That's the weakness. Okay, three charged particles in air are located at the corner of an equal lateral triangle shown in the diagram. Charges plus Q1, Q1, Q2, Q3, values given. The distance between the particles are 1.0. Right? So know that all the angle is 60 degrees. Determine the magnitude and direction of the net force on Q1. Right? That's your Q1. So between, right? Formula, write down. Right? If you don't know the formula, write down. Examiner will give you the mark. Right? Between Q.
Even if you don't even know, do just write down the formula.
Yeah, I think they will give you a mark if it's related to the question. Right? Q3 and Q1.
If I know the topic, then should be okay lah.
Yeah, do it. But anyway, show the formula in case you are careless, you're careless, you may lose mark unnecessarily. Write the formula. I think at least it will give you 1 mark. So between Q3 and Q1, there's a repulsive force going away. Right? I write 3, 1. Then between Q2 and Q1, there's a repulsive force also. Okay, F21, I've calculated out for you. Right? F2 is 100. That's 100. Change it to SI unit. S1. Okay. S1 is that one there. 1 times 10 to the power minus 6. Right? Instead of using 4 pi times that, you can use 9 times 10 to the power 9. If you feel you can remember that. Okay. 3, 1 is this one. Calculate out. Right? They are the same. Actually, no need to calculate it. They are the same distance. And then
Yeah, I can't see your screen.
Q3 is the same as Q2. Right? And then
you're not showing your screen.
Say again.
You're not showing your screen, it's showing the internet thing.
Oh, sorry. Should have told me earlier.
So I'm thinking, why did you explain without the thing on something wrong?
I didn't okay, I record again. Right? First, between Q3 and Q1, there's a repulsive force F31. That's F31. Right? F3, this is your F3. That's F3, the Q100, the 10 to the power minus 6. Then Q1 is your 10, 1, the 10 to the power minus 6. Then the others are just a constant, and then the 10 cm, we change it to meter square there. Right? Q21 the same. Q2 and Q1, Q21, right? Drawing a bit bad lah, but they are the same. They're the same value. Okay. Q1, there's your Q1. Q2, there's your Q2. Okay. Same answer. And complete your parallelogram. Okay. In fact, you don't need to you realize that the force is vertical. Resultant force is vertical because these two are the same. And this angle is 30 degrees. This is also 30 degrees. Okay, so it becomes a rhombus, and this is vertical. And then you just resolve it easier lah. Resolve it is 900 cos 30 for this side. 900 cos 30 the other side. That's why there's a 2 there. Multiply that out. Vertically upwards. Then calculate the percentage of electrostatic force reduced when air is replaced by water with relative permittivity 80. Okay, so this value F31, F21 will reduce by 80 and divide by 80 at the same value. Right? Resultant the same. Resultant is just use 113 cos 30, and there are two of them. One is for this one for that one there. Percentage reduction. Right? Take the original value minus this value. Divide by original value to 100%, so it's 98.8. Okay, if you prefer you can use this triangle to calculate out if you want to. It take a bit longer. This triangle, which is this one, 9,000, 9,000, and then this angle is 120, this 30. You can use this one if you want to. Cosine rule. Resolving is faster. Any question on this part? Anything not clear? Okay.
Okay.
Based on your answer.
Go back again. Okay.
Right? Based on your answer in 2, explain why cooking salt dissolve in water easily. Okay? Based on your answer, that's all. What's happening? Force of attraction between the sodium and chloride ions. Right? If it's air, that is very strong, very large. However, you put water there. Right? Water is a dielectric, so it reduces the force between them by almost 100%. So that's why the force is so little that they dissolve. Define Gauss law, right? You find Gauss law, make sure you know how that. Very popular. Make sure you know how to state that the electric flux through a closed surface is given by the ratio of the total charge enclosed to the permittivity of the medium. Okay. A thin conducting square with length 10 cm. So it's 10 by 10. In free space has a total charge of 60 microcoulomb. Determine the magnetic direction of the electric force. Right? Memorize the formula. Right? Charge density is Q divided by S. Right? That's your Q. Remember, 30 one side, 30 the other side. Okay, half on one side, half on the other side. That's why we got 30. And then this one change to meter, it's a square. The surface area is 0.1 square. Right? Simplify that. And use the formula. E is surface charge density 2 divided by 2 epsilon naught. Put in your value, calculate out. Can? Anything not clear?
Okay.
If it's okay, let's go to the next question. Okay, let's say by using a hollow, what is happening? Why did I put a different color? Define Gauss law. Oh, define Gauss law the same. You can see a popular question. And then number 2B, a hollow isolated conducting sphere with radius R carries a positive charge with surface density that by using Gauss law derive an expression for the electric field strength E in terms of all that a distance R from the center of the sphere where R is less than the radius of the sphere and R greater than the radius of the sphere. Okay, first look at R less than that. Remember the charge is on the surface, no charge inside there when it's less than R. So using this formula, that's your calculate your flux dA. In this case, no charge, so no electric field. And for R greater than R, right, you're just using Gauss law. That's your Gauss law. Surface density 4 pi R times 4 pi R squared. Right? Surface of the sphere divided by epsilon naught. And then flux, you calculate by electric field strength times the area, surface area, that's your surface area that you have taken inside the conductor. Then take this one down. I put a different color because your answer in your book is different. It should be this answer. Okay.
Okay.
I think your book remove the R, all the R. The two R are different. Don't get confused.
Repeat again, sir.
The two R is different. The capital R and the small R. I think your answer give the wrong. The answer get confused. Right?
Maybe printing error, I think.
Cannot be printing error. Capital R is the radius of the
small
sphere.
R do different.
The charge is reside on the surface of the sphere. That's why if it's less than the radius of the sphere, there's no electric field, no charge there. Okay. Sketch a graph of E versus R. That one is memory work. That's all. E versus R. Inside there is 0. Outside there, decreasing. Draw a diagram showing the charge distribution and the electric field line produced by the sphere. That's all. Okay, the charge is on the surface. Right? It should be coming out perpendicular to the surface and a straight line. Okay, any comment?
Nope.
I have a feeling you didn't do your homework.
I did, teacher. I mean, not fully, 70-80% I did.
Last part of revision
Hello?
is do your homework. If you don't do your homework, you will lose out. You cannot afford this semester because this semester you don't score. Next semester is even tougher, where you are going to repeat and then you have new syllabus. Okay, let's go to number 3. Now 2C, Van de Graaff generator consists of a metal sphere with radius as a radius 20 cm. Breakdown, electric field strength is given. Calculate the maximum quantity of charge which can be stored in the sphere. Basically getting you to use the formula, that's all. That's the formula. Electric field strength is given, radius is given. Then you want to find charge, that's all. Take the 4 pi epsilon naught out across to get this equation, put in your value. That's the electric field strength, that one. 4 pi epsilon naught as a constant. And then your 20 change to meter, 0.2 square. Use your calculator and calculate out. State one way to increase the maximum quantity of charge to be stored in the Van de Graaff generator. Okay, how to increase the maximum quantity of charge? Can? Any idea? Look at this equation, that's all. Yeah, the equation.
Use a sphere with larger radius.
Larger area, there's a larger radius. Right? Increase the radius of the sphere. That's all.
So this is just basically trying to test the knowledge.
Usually the application part, go back to the formula that you use. That's all. Testing you, see whether you know how to apply your knowledge or not. Okay, let's carry on to number 3. Define electric potential. Okay, define for me. Yep. How to define electric potential? 1 mark only. Can?
Just a minute, sir.
This one offhand should be memory already. You should be able to tell me straight away.
The electric potential at a point is the work done in bringing a unit charge from infinity to that point.
Yeah, it's the work done in bringing a unit positive charge from infinity to the point. Okay, two spherical conductors X and Y, which are located at certain distance apart, are shown in diagram below. X is our radius, 0.15 cm, carries a charge of plus 8 microcoulomb. Y is our radius, 0.3 cm, and carry a charge of minus 2.0 microcoulomb. Determine the charge which remains on X and Y. Remain on X when X and Y are connected by a wire. So how to solve this question? Any idea? One is positive charge, one is negative charge. Yep, any idea? No idea.
Use the delta Q over epsilon, that formula.
You should know all these things by heart already. Charge will flow until both spheres have the same potential. That's a key concept. The charge will flow until the potential is the same. So it means that the electron will flow from Y to X until this is 0. So it means that after that, the distributor 8 minus 2 is 6. Distributor, this is a 6 microcoulomb until the two of them have the same potential. Right? So I'm just using that formula for potential. Okay, Vx initially, I'm using that as K. That as K. So we are told that, refer to your book if you are lost. This is 8, this is 2, 8 here, 2 here. Replacing the Q with your 8, and then the radius, that one. Okay, I didn't change it to meter yet, doesn't matter, because I'm more interested in the charge as well. I'm not calculating potential, but if you are particular, change it to meter if you want to. Calculate out, then Vy initially, minus 2K, and then this one, 0.30 meter, calculate out. And final potential, what I'm doing, I'm taking the average of these two values. Average of these two values, I got that. Then calculate for each one. Okay,
Okay.
23K, put in your value. That's your K, QX, 0.15. Right? Remember that's the final potential. So I'm now applying back to here, right? 23.3. That's my K, right? K, and then QX, 0.15. That's the radius. And calculate my QX. Then the same potential for Y, K, QY. That's the radius of Y. And calculate out. Okay. So I'm more interested in if I use initial value as 3 initial value as micro coulomb, then I get micro coulomb, right? I didn't change it this one. I use micro coulomb, I get micro coulomb. Right? If you want to change your SI, go ahead. It's just that I see it's a lot of unnecessary work lah. Unless you want to calculate the actual value of potential, then you convert all to SI unit. But in this case, you are interested in the charge on X and Y. Yep. Any comment? I think my answer disagree with your book answer.
Oh.
The charge cannot be the same. The potential is the same. Unless they have the same radius, then they have the same charge. Yeah, different radius will have different charge. Right? Potential is the same. That's why we have to calculate the final potential first. Final potential. And use this formula again to calculate the charge on QX and QY. Yep. Anything not clear? Make sure you have to do your homework. If not, you are going to lose out. To me, I see essay and structure are more marked there. Okay, let's carry on. An electron is accelerated from rest through a region between electric potential V1 and V2 in vacuum. The final speed of the electron is given. State the transformation energy of the electron. Okay, transformation energy. Yep. You accelerate through potential V1 to V2 in vacuum. So what is the transformation energy? Electrons start from rest, and then that's the final speed. Yeah, the question itself will give you some idea already. Okay. V1 is high potential. Sorry, V1 is lower potential. V2 is higher potential. You are told is accelerate. Right? So V2 must be higher potential. So it's loss in electric potential energy equals to gain in kinetic energy. That's the energy transformation. Electric potential converted to gain in kinetic. Right? That's the first hint they try to help you so that you can calculate the next question, determine the potential difference V1 and V2. Right? So as long as you can get a transformation energy, then the next part is just that kinetic energy, gain kinetic energy, your work done, or the loss in potential energy. Okay, I want to calculate your potential difference between V1 and V2. I call that V. Take the E down, got the equation. Get it from your data sheet. Physical constant, mass of electron, speed is there. 2 there, charge of electron, get it from the data sheet and calculate out. Can? Anything clear?
Okay.
Usually they will calculate, they will essay question, they will try to cover all the question, right? All the different parts. An electron move along a line in the middle between a pair of parallel metal plate as shown in the diagram below. But remember, it's midway. The initial horizontal velocity of the electron, that's the velocity of the electron. The electric potential of the upper and lower plate is +6 -6. The separation between the plate is they have given you 1.0 cm. Calculate the acceleration of the electron between the plate. So what should I do? What should I do? Calculate the acceleration. I must know the force. To calculate the force, I must know the electric field. So to calculate the electric field, how to calculate the electric field strength? Not ready yet, you. Not ready yet. There's your formula. VD. There's your 6 minus potential difference. 6 minus 6. And then that one, cm change to meter. Calculate out. And calculate your force. F is EE. And equals to MA. Right? Calculate your A. Take your M down. So your E, you have already calculated. Change it to SI unit. And the charge on electron. Charge on electron. Mass of electron. And calculate out. Determine whether the electron can exceed the end of the plate. To exceed, you must not touch the plate. So from that one there, you can calculate the distance between these two is 0.5 cm. Then calculate as it leaves, right? What's the vertical height? So the first step, distance. Okay, sorry. Okay, first calculate the middle one, right? The vertical height from the electron to the plate. This is what I'm doing, right? Half of this one. Then I calculate the time to travel horizontal distance, time within the plate, right? X divided by U. Remember the speed given is horizontal speed. Calculate your time. Right? This is your last semester work. And after that, look at vertical motion. Vertical motion, U equals 0. A is there. Right? You want to find Y. Right? Vertical S is your Y. Y is 0. Remember, the speed given is X. UX, not UY. UY is 0. Vertical speed is 0. And then there's a formula for half AT square. Put in your value. This one is 0. Half acceleration. That's your acceleration. And then there's your time. That's your time. Okay. So Y is 1.6. So what does it tell you? Yep. What's your conclusion? Yep. Yep. How do you read from this 0.5 and 1.6? What's your conclusion?
Since the calculated vertical deflection greater than 0.5, the electron cannot exit from the end of the plate.
You will hit the plate, that's all. You won't exit. Right? You will hit. That's all. Good. Okay. Any comment? Any question? Anything not clear?
No, all okay.
State electric potential at a point. Okay. Electric potential at a point. Memory work. This one you should score 1 mark. Yeah. What's electric potential at a point? No need to refer. All this should be in your head already.
It is the work done in bringing a positive charge unit from infinity to that point in the electric field.
Not only a positive charge, unit positive charge. At a point in the electric field is the work done in bringing a unit positive charge from infinity to the point. Then in the diagram, draw equal potential surface, equal potential line where the electric potential is 0. Right? 0 is here. Right? 0 is at the where is perpendicular. The surface is perpendicular. The green line. Derive expression for work done to separate the charge to infinity. Okay. There's a potential for one charge. Right? Okay, work done from x to infinity. Force times your distance. What am I doing? What happened to the what happened to it? Yeah, how come it's not shown up? Right? So that is your force. K Q over distance is x squared dx. Then integrate it all. X to infinity. And that's why you get. Okay. Any comment?
No. Not yet.
Okay. We are going to stop soon anyway. Okay, 3 charges minus Q plus Q plus Q are placed at the corner of a square dimension LLL. In terms of Q, L, and epsilon naught, determine the expression for the electric field strength at A. Okay, draw one by one. Right? Find the diagonal. Right? Diagonal LL 1 root 2. So it's L root 2. That distance. Diagonal. Right? That's the formula we are going to use. So write down. Right? Yeah, at least 1 mark. And then E1. Right? E1. E2. That's your E1. Because this is a negative charge, the electric field is going towards it. And E2 is this one. That's your L. Right? 4 pi epsilon naught. L square. Sorry, what have I done? Oh, sorry, this is the one. 3Q, that one is E1. That's your E1. Sorry, that didn't label it. That's your E1. And then 3Q, 4 pi epsilon naught. That distance is L. Whereas Q2, that's your attractive force. Right? Don't worry about negative sign. when it comes to vector, it just show the direction. So that's your L root 2. So I put my L root 2 here. That's why we get our 8 here. Okay, E1 and E3 the same. Right? E3 and E1 is same. Okay. So these two are the same. E1, right? One is E3. So these two resultant will give this direction, right? From your parallelogram. Right? So they are the same. So it's E1 root 2, right? 1 root 2. So E1 root 2 resultant expression, right? Remember they are on the same line. So E1 root 2, that's your E1, 3Q times the root 2, right? 4 pi epsilon naught L square. Then this one is your E2, which is this one here, minus. Okay, this is positive direction, this is negative direction. That's why minus, then simplify it all. Put in your value for epsilon naught and simplify it. Okay, we'll stop here. Any question? You can try the rest. As I say, you have to work it out. No point in coming for tuition if I do for you the work, you don't learn anything. You have to force your mind to work.
Yes, teacher.
Okay? It's a waste of money. You come like that. Okay, I see you tomorrow. Make sure you are ready for the quiz. I'll stop here.
Yes. Yes, teacher. Okay, thank you. Thank you so much.
Okay, see you tomorrow.
Bye.